All right, welcome geometry students. We're going to be looking at a lesson today. I'm not going to fill in the dates, but the learning target says I can use SOH CAH TOA to solve for sides in right triangles. So we have a warm-up here. It says use a calculator or table of trig values to evaluate each expression. You may or may not have a table of trig values. I'm going to use the calculator here. So to find the sine of 39 degrees, the cosine of 25 degrees, tangent of 81 degrees. So I'm going to use a calculator for those. So depending on the calculator that you use, at the time of this recording, my classroom set of calculators, you have to put the angle measurement in first. So sine of 39 degrees, we're going to do 39 first. Then you have to ask the calculator to do the sine of that angle. So there we go. And then rounding instructions, 10 thousandths is decimal point and 4 more digits. So we got 0.62932. Rounded is 0.6293. So there we go. So there's our first problem done. Now, if you had a table of trig values, it would already do the rounding for you. And trig values trig tables, tables of trig values commonly go to 4 digits, the nearest 10,000. Okay. So the same thing with cosine of 25. Grab a calculator, or if you have a table of trig values, look that up. So my calculator is telling me the cosine of 25 is 0.90630. Again, to 4 digits to the nearest 10 thousandths, that'll round to 0.9063. So there we go, got that written down. And then tangent of 81, again, I'm going to go to the calculator here. And again, depending on the calculator you use, you might need to start with the angle 81 and then ask the calculator to do the tangent of that. So we got 6.31375. That's going to round us to 6.3138. And just to keep in perspective, what the heck are we doing here when we're having the calculator do the sine, cosine, or tangent of these angles? I'm just going to take the last example and say, what if we had a right triangle and we had an 81-degree angle? The idea would be that the ratio, remember tangent is opposite over adjacent. That's the TOA of SOH CAH TOA. So it's saying like, you know, maybe it's x and y. If you were to divide the opposite leg, I'm calling it x here, by the adjacent leg y, you would have x divided by y would be approximately 6.3138. So just to keep that in perspective there. Okay, but there's our warm-up. So we've got a blank to fill in here. It says, when using a calculator for sine, cosine, and tangent, make sure it, meaning the calculator, is in degrees. That is something, there are other ways to measure angles. You know, just like you can measure a distance in feet or inches or centimeters or meters or yards or miles or kilometers, whatever. Angles can be measured in other units besides degrees. We're not going to bother with the other ways to do it, but just make sure your calculator's in degrees. If you were putting these numbers on your calculator and you were getting different numbers, my first guess is maybe your calculator is not in degrees mode, okay? But let's keep going here. So our next section says we're going to solve some equations with trigonometric functions. Our instructions say solve each equation for the variable, and then we have rounding instructions. So this could be, maybe this situation is, maybe I have a triangle with a right angle, and maybe there's a 47-degree angle. And the sine, this is the SOH of SOH CAH TOA, so it's defined to be the opposite leg over the hypotenuse. So maybe x represents the opposite leg and 22 is the hypotenuse, and maybe I want to figure out the value of x. So maybe I write down this equation. Okay? Well, I can go to the calculator with the sine of 47 degrees, and I can say, all right, what is the sine of 47 degrees? My calculator tells me, again, I'm going to go to 4 digits, 0.73135. That's going to round to 0.7314. So using the calculator for that there. Now, some of you might know, like, oh, I just have to cancel division by 22. Yeah, you can do that. I'm going to still put this decimal over 1, and now I'm going to cross multiply. So we've seen cross multiply and divide before with our proportions. So we've got the 22's diagonal from that decimal. Those are going to get multiplied, and then we're going to divide by the 1. And I've got on my cheat sheet here, if we punch that in, we get 16.0908. And then following our rounding instructions, nearest hundredth, we got a 9 in the hundredths place with a 0 next door. So this would be x is approximately 16.09. Okay. So we just solved a trigonometric equation there. Okay. Looking at number 5, similarly, if we wanted to think about this as coming from a triangle, maybe we've got an 18-degree angle here, and tangent is defined to be the opposite leg over the adjacent leg. So maybe that's 35 is the opposite leg and y is the adjacent leg. This is the TOA of SOH CAH TOA. So I can go to the calculator and say, all right, hold on, I can do the tangent of 18 on the calculator. What does the calculator tell me? If I can bring that up here, 18 degrees has a tangent of 0.32491. I'm going to round that to 0.3249. 0.3249. Now this one here is, within the last problem, if you're just like, oh, I could just multiply both sides by 22, that would cancel. I mean, yeah, that works, but let's go back to, here. Here it's a little more difficult because you're not dividing by 35, you're dividing by the variable. So this is really where I would recommend put that decimal over 1 and then do your cross multiply and divide. So we'd have 1 times 35, those are our diagonal numbers, and then we would divide by that decimal. And you can punch that into the calculator. Again, going off my cheat sheet, I've got 107.725. It keeps going, but rounding to the nearest hundredth, we've got a 2 in the hundredths place with a 5 next door. So this would tell us our value for y would be about 107.73. So that'd be our answer there. Okay. So this is where 4 and 5, we were given these equations. I kind of set up what it would look like with the triangles. So the next section is where we're just going to start with the triangles. We're going to have to come up with the equations. But one thing just to remind you of, when you have the tangent of an angle or the sine of an angle or the cosine of an angle, if you know that angle, just like we did in the warm-up, that's a number. So if you have the sine of 39 degrees or the sine of some known angle or the cosine of a known angle or the tangent, again, if you have the table of trig values, you could look that decimal number up or punch it into the calculator and proceed from there with your equation. So let's jump down to the next section here. So now we're going to solve for each variable and we're going to round. We've got rounding instructions. So first thing I'm going to do is I'm going to label all the sides here and I'm going to decide which function should I use. So should I do sine, cosine, or tangent for 61 degrees? Well, I know the hypotenuse is opposite the right angle. Down here, this is going to be the opposite leg to 61 degrees. I'm being lazy. I'm not writing leg, but keep in mind it's an opposite leg. And by the way, in this case, I don't know and I don't care about the opposite leg to 61 degrees. In some situations, maybe I will care, but that leaves K as the adjacent leg to that 61 degree angle. So I look here for myself and I say, all right, we know the hypotenuse and we want to know the adjacent leg. So in SOH CAH TOA, am I going to use sine, cosine, or tangent? Which one involves hypotenuse and adjacent leg? Well, let's see. Sine has hypotenuse, but it's got the opposite leg. Okay, so not that one. Cosine has adjacent leg. I want to know that. Has hypotenuse. Okay, cosine sounds good. Let's just double check tangent. Tangent involves the opposite leg. I don't know and I don't care about the opposite leg. So it sounds like we're going to do cosine here. So we're going to make this look like the previous problems. I'm going to write down the equation, the cosine of that 61 degree angle. The definition is adjacent over hypotenuse. So the adjacent leg is K over the hypotenuse of 34. So if you can get to that point, you've made the problem look like the previous two problems. So now we just have to solve this here. So I encourage you, if you haven't tried it out on your own, maybe pause the video here. I'm going to jump ahead a little bit. Okay, so punching cosine of 61 into the calculator or looking it up in a table. Cosine of 61 degrees is 0.4848. That's rounded. I can put that over 1, and then I can cross multiply and divide here. So K is going to be the 34 times that decimal, and then divide by the 1. And I get, going off my cheat sheet, 16.4832, keeps going, but we're rounding to the nearest tenth. So we're looking at the 4, we got the 8 next door, so that means K is approximately 16.5. Okay. So again, I encourage you, if you haven't done number 7 yet, maybe pause the video, see what you can do there. But otherwise, if we're looking at the 25 degree angle, let's see, the hypotenuse in this case, opposite the right angle. I don't know, I don't care about the hypotenuse. So I already know which function we're going to use, sine, cosine, or tangent, if we're not using the hypotenuse. But let's just keep going here. So we've got the opposite leg to 25 degrees is h. That's the opposite leg. Again, I'm being lazy, not writing leg. And then the 20 is the adjacent leg to the 25-degree angle. So we're doing, we've got something that involves the adjacent leg and the opposite leg. SOH CAH TOA, sine, cosine, or tangent. Which one involves the adjacent leg and the opposite leg? That's going to be tangent. The other two, sine and cosine, involve the hypotenuse, which we don't know and we don't care about. So I can write myself an equation. I can say the tangent of 25 degrees is equal to, was that h? I wrote over there. H is the opposite leg over the 20, and I can solve this equation. Okay? If I grab the calculator, I punch in the tangent of 25 degrees. I like to round to 4 digits, so it's 0.3249. That's h over 20. You want to make that into a proportion, put that over 1, and now we can cross multiply and divide. That decimal times 20 divided by 1. My calculator gives me here 9.326 something, and then to the nearest tenth, 9.2 with the 3 next door. H is approximately 9.2 units here. So one more thing I'll say before we go to the next page. Remember, we want to ask ourselves a question when we're solving for these side lengths to say, is our answer reasonable? Is it reasonable to say that H is 9.2? Whoops, if I can spell here. Is it reasonable that H should be 9.2 units approximately? Going back to the previous problem, is it reasonable that K would be 16.5? Well, for number 6, we know that 34 is the hypotenuse, so this should be smaller or less than the hypotenuse. So that's reasonable. Okay. If I got 34, going back to number 6, if I got 34 or something bigger than 34, I go, uh-oh, I got a leg that's bigger than the hypotenuse. That is unreasonable. Number 20 is a little more difficult, perhaps. We can figure out that this bottom angle is 65 degrees. And I'll see if I can squeeze in here. That's the triangle angle sum. All three angles add to 180. So 180 minus 90 minus 25 leaves you 65 degrees for this bottom angle. And in that case, when we're talking about the acute angles, the angles that are smaller than 90, 20 is opposite the bigger acute angle compared to H. So we should get something smaller than 20. So that's less than 20. It's, thinking back to like 30, 60, 90 triangles, we talk about the short leg and the long leg, H should be the short leg. It's opposite a smaller angle compared to 20. So that is less than 20, so that makes it reasonable. So I just always encourage you to think about, is my answer reasonable? Because sometimes that can help you spot a mistake. If you have an answer that seems unreasonable, it's probably wrong. You probably have a mistake somewhere. Okay, I'm going to scroll to the next page here. All right, so everybody's favorite story problems. Our story problem says Amy's cat is stuck in a tree. She stands 10 feet away from the base of the tree and looks up to her cat at an angle of 75 degrees. We could say the angle of elevation from Amy to the cat is 75 degrees. Real quick, angle of elevation. If you are looking straight out horizontally, so maybe this is your eye line, whatever, this is your line of sight. But then all of a sudden you hear a noise, or there's a cat in the tree, or you're looking up to the top of a building or something, and so you look up. This would be the idea of your angle of elevation. Okay, elevate means to raise. So imagine you're looking straight ahead, but then you raise your line of sight. That would be the idea of angle of elevation. All right, so what are we supposed to do here? Number 8 says we're supposed to draw a right triangle to represent the situation, label the known measurements, and label the cat's height in the tree as H. So I encourage you to pause the video if you want to try your own diagram, but I'm going to pause it here and come up with my diagram. All right, so here's my diagram. Keep in mind your diagram might look different, and that is potentially okay. Of course, there's some diagrams that could be wrong, but so I've got Amy standing over here on the left, the tree's on the right, the cat is up in the tree. We're told Amy stands 10 feet away from the base of the tree, so I got my 10 feet labeled there, 10 feet from the base, the bottom of the tree, and then Amy looks up at an angle of 75 degrees, so I got that there. The only other thing I would probably mention, and usually is, well, I don't know. On my quizzes and my tests, I usually tell you, we would probably assume that the tree is perpendicular to the ground, meaning the tree creates a right angle with the, if you know that. Because we're doing right triangle trigonometry right now. So it's kind of like, well, I think we need to have that right angle. We need a right triangle in order to proceed with this. So, all right. So there's from the story. There's our diagram. Okay. Basically just coming up with a triangle and labeling known angles, known sides, and the side that we're ultimately going to care about, which is the cat's height h. Okay. So now we've got number 9. We want to write an equation for the triangle using SOH CAH TOA. So we'd say, all right, okay, in regards to this 75-degree angle, what sides do we know? What sides do we care about? Well, the hypotenuse is here. We don't know. We don't care. So again, you might already say, I think I know which trig function, sine, cosine, or tangent we're going to use. 75, opposite to 75 rather, is h. That's the opposite leg to 75 degrees, and the 10 feet is the adjacent leg to that 75-degree angle. So we're dealing with the opposite leg and the adjacent leg. SOH CAH TOA, that's tangent. So our equation would be the tangent of the angle, the tangent of that 75-degree angle, is equal to this fraction, the opposite leg of h, over the adjacent leg of 10 feet. So there's our equation. That's all we had to do for number 9, write an equation. Okay. And then number 10 says, how high up is the cat? Well, remember, we were using h to represent the height of the cat. So basically, this is just saying solve for h. We have an equation here, and we can take that equation and we can solve for h. So just like we did, you can go back to the previous section. I encourage you to pause the video here, see if you can solve this if you haven't. But here I go. We can type in tangent of 75 into the calculator. And I get rounded to 4 digits, 3.7321. That's still equal to that fraction, h over 10. I can make the decimal into a fraction, put that over 1. I can cross multiply and divide. So the 3.7321 multiplied by the 10 and divided by 1, and that's going to give me 37.321. Now that's exact based on the numbers I have there, but it's still rounded because the 3.7 whatever is rounded. But here I got rounded to the nearest tenth of a foot, so we're looking at the 3 with the 2 next to it. So the cat is about 37.3 feet high. About 37.3 feet off the ground. There we go. So there's our story answer to a story question. We just have one section left, and then we're all done with these notes. So just to kind of take you through what we've been doing here for a lot of these problems, when we just start with a triangle, and we're supposed to solve for a side length in this right triangle. So first thing I do is I identify the sides. So which side is the hypotenuse, which side is the opposite leg, which side is the adjacent leg. But that's based on what we call the reference angle. You know, if you've practiced this enough, you know that, I mean, the hypotenuse is the hypotenuse. That doesn't matter. Like, well, were you talking about the 75-degree angle or the 15-degree angle, or which angle are you talking about? The hypotenuse is the hypotenuse. But the opposite leg depends on the angle you're talking about, and the adjacent leg depends on the angle you're talking about. So go ahead, write those on the triangle. It's a good habit to label it on the triangle, write those things down. Then, based on the side you know and what you want to know, decide which function or ratio to use. So that would be sine, cosine, or tangent. So we've seen some examples here where we go, oh, because between what we know and what we want to know, we're going to use the sine. Between, you know, if it's opposite and hypotenuse, we know one of them, we want to know the other. So between opposite and hypotenuse, we'd use sine. Or adjacent and hypotenuse, we'd use cosine. Or opposite and adjacent, we use tangent. Okay. Then we can write an equation using that chosen ratio or function, sine, cosine, or tangent. Okay. Again, you can go back in the video and see where we said we're going to use the sine, and so let's write an equation based on sine of the angle. Next, we would solve that equation. So we got lots of examples there. Some of them where we just started with an equation. Okay. And then last thing, consider if your answer is reasonable. So some things to remember there, we talked a little bit about in this video, that, like the hypotenuse is supposed to be the biggest side, or to rephrase that, the legs should be shorter than the hypotenuse. The hypotenuse should be longer than the legs. But then also, like, a bigger leg is opposite a bigger angle. And a smaller leg is opposite a smaller angle. Is opposite. Let me spell that out there. Bigger leg is opposite a bigger angle. There we go. Okay. So again, just to think about, is my answer reasonable? Sometimes can help you. Sometimes you can go, oh, my answer is unreasonable. There's probably a mistake somewhere. Okay. I hope you found that video helpful. See me in the next one.